All right, happy Monday. So guess what, guys? This is our first day of in-person learning for the Pod A. So my homeroom, my original homeroom, people that have come back for hybrid, they are coming into the building right now. They're working today. Well, we'll see if we're going to be working today, but we're going to be figuring out like how we do all of our things, like our temperature checks, and you got to do wet wipes. You got to sit at desks that are really far apart. I'll send you guys. I'll send everybody photos. I'll send out photos of what it looks like in my classroom with like 10 desks all spread out. We got an air purifier. Windows are going to be wide open, but it's a beautiful day. So I think that's going to be fine. Right. But, really interesting, this new transition, which I'm excited about. I'm also a little apprehensive or nervous about it because there's always that figuring out how we do something. So the biggest challenge is going to be teaching both in person and online at the same time, right? Because I'm going to have some students at home today and some students in my classroom that I have to teach all together. So but we will figure it out. All right, today's note card. I hope you started your bowing a notebook. This is another thing that we do every week, but our note cards. Factoring expressions, a new thing. It's like distributive property, but the opposite. So I'd like you to write this down. Factoring is the opposite of distributing because you divide to remove a common factor from the terms. So instead of multiplying, where distributing is like, remember, handing out, distributing cards, distributing something, you're basically multiplying it out to all the terms. Factoring is the exact opposite of that. You are dividing out a factor, a common factor from the terms. So you'll see when we finish these problems, you'll be like, oh, the ending point of a problem like this looks like a distributive property problem, right? And the beginning point looks like the answer to a distributive property problem. So you're going to see that. So write this down. Factoring is the opposite of distributing because you divide to remove a common factor from the terms. All right, the first one we're going to do, we'll do it. I'm looking for all these kind of clashing colors. I'm going to try to make all the colors look awful today just because I think that'll be interesting. Okay, first one we're going to do 2a plus 6. All right. Now that problem, we are stuck where we cannot do anything to it. I can't add a variable term with a constant. 6 is worth something. We know what 6 is worth. We do not know what 2a is worth because a is an unknown. Therefore, what we need to do is say, can we change it? Can we do anything to it? And much like we said with distributive property, when we are stuck, we could multiply the term through. In this case, what we have to do is take a term out. So we look and say, what are some common factors with 2 and 6? Is there any number that goes into both of them? And so what we're going to say is our kind of like key here is we're going to say, well, let's divide the whole thing by 2. So what we're going to say is if I divide it by 2, if I divide everything by 2, I'm going to put this over here, divide by 2, right? This is what I'm going to do. I am going to take both of these and change it. I'm going to divide 2a by 2, and I'm going to divide 6 by 2, right? So this is our step. This is what we're doing, right? And what does that end up looking like? Well, you can draw it this way if you want to. You don't have to, but I'm going to draw a line and draw the new term. When I divide 2a by 2, I'm going to go back to green. I think it was this green. I end up getting just a, right? What happens to the 2? They go away. And when I divide 6 by 2, I end up getting 3. But I bring down the plus sign, right? That all stays. That's coming from here. So it's a plus 3. What do I do with the 2 that I took out of there? Well, I put it in front. I make this a quantity, and I put the 2 out front. Now notice this answer looks exactly like a distributive property problem, right? If we were going the other way, we would say 2a plus 3, and you're going to see it goes right back. Remember distributive property, which we've talked about a number of times over the last couple of weeks. Distributive property tells me I can do this, right? So this is going, now I'm doing distributive property, and I end up with, and let's go back to my beautiful green, let's end up with 2 times a is 2a, 2 times 3 is 6. So notice we started here, divided, took it to distribute to this term right here, which is the answer to a factoring problem, and then we distributed it back out, and we notice that we come back to all the same. So all of these expressions are equivalent. They're all the same, right? Okay, we're going to do another one. Let's draw a line right here. Do we want a green line? Yeah, why not? Okay. Second problem. Let's do this one in a blue. We're going to do 25y. So write this down. 25y plus 10. Now, once again, I look for a common factor. I can't do anything to it because 25y cannot be added to 10. However, I can find a common factor. So my common factor, I'm going to go back to the black, is going to be divide by 5, right? So I'm going to divide by 5, put this in a circle. I don't have to do that. I'm just kind of showing you. And then over here, I'm dividing each term by 5, right? So both of these get divided by 5. I draw that line, and now I rewrite the problem. So I go back to my blue, which I think it was this blue. I'm not even sure. And 25 divided by 5 would give me 5y. 10 divided by 5 would give me 2. I bring down the plus sign since I started with it, right? That plus sign comes down here, right? And now I'm at 5y plus 2. That makes sense. That works. And now what do I do with the 5 that I divided by? Well, I put the parentheses, and I put the 5 out front. And now notice, this is a distributive property problem. That's my answer. I'm done. This is distributive property. So if I go 5 times 5y, I get 25y. If I go 5 times 2, I get 10. And those are equivalent expressions, right? Great, right? Isn't this easy? Not hard at all. You just got to practice your factors. No kind of like look for division. So we're just looking for a way to write an expression in a different way, right? That's kind of what this is all about. Writing expressions in different. We already used purple. We can't use purple again. Let's go with, have we used pink? I don't think so. All right, pink. Let's go with one more. Let's go with 16x plus 40. This one's a little trickier. Once again, the numbers can get more complicated. Notice I'm using different letters each time because that doesn't matter. We just know that we can't add a variable and a number. So what I'm going to do now is look for what goes into both of these. So I'm going back to my black, right? And I'm going to divide out. I can say, well, 16 doesn't go into 40. But they're both even. 2 goes into both of them. But I look for a bigger number. What about 4? 4 definitely goes into both of them. 4 times 6, 4 is 16. 4 times 10 is 40. But you know what? There's one even bigger. I can go 8. So I can divide by 8. Now, if I did 4 or 2, I would notice that I can do distributive factoring again. But in this case, 8 goes into both numbers. So what we're going to do is we're going to divide this by 8. Right? This is factoring, dividing instead of multiplying. And we're going to divide this by 8. We're going to draw our line, and then we're going to come back here and find that pink again. And we're going to say 16 divided by 8 would give me 2x. 40 divided by 8 would give me 5, right? And that's a terrible looking 5. And I got to bring down the plus sign again, right? So the plus sign stays. Now, the last thing I have to do, put it into a quantity, and write in the 8 out here. And that means 8 times 2x, 8 times 5. This expression and this expression are the same, right? These are great. This is factoring. Yay! Okay, that's like not a very good happy face, but yay for factoring. Yay! Maybe bigger eyes would be better. Okay, that's a little better. Weird eyes. Okay, yay for factoring. Now, I want your note card to be, please complete your note card. And then I'd like you also to take a look at these other problems that you can practice in class right now. These problems are what I'd like you to do in class. 7x plus 28, 16y plus 12, 15 plus 21n, and a longer one, you can do it with 3 terms. 30x plus 20y minus 100. See if you can work through those. Those are all to be in your notebook as well. If you need a little bit more time, if you need some help from your teacher, if you want to email me at some point or talk to a friend, like I think you guys can figure this out. But the same thing with factoring. All right, kids. Have a great, great day. Happy Monday. I'll see you. I have another video going tomorrow, and hopefully I'm looking forward to seeing you all Wednesday. Bye, everybody.